Hello, Dr. Mashburn, and today we'll continue our lectures with the lymphatic system. And the lymphatic system is a system that kind of parallels the circulatory system, the arteries and the veins, and its job is to return lymph to the blood system, to the heart and to the blood, and then to the back to circulation. How about that? Sorry, I'm trying to get my pen and talk at the same time, which is never a good idea. Okay, so it returns fluids that leak from the blood vessels back to the blood. All right, and so if you remember from arteries and veins, you have arteries, and then you have capillaries, and then you have veins, and this is where exchange takes place. And one of the things that happens in that exchange is hydrostatic pressure pushes fluids out, and then osmotic pressure brings those fluids back in. Well, the fluid, as it's leaving and coming back, there's going to always be fluid around the capillary bed. That's called the extracellular fluid, but in particular the interstitial fluid. Okay, and this interstitial fluid, it needs to be recycled, and so it will enter into the lymphatic vessels, and when it does that, we call it lymph, and then that can be taken back into circulation. And so the lymphatic system works to return these leaked fluids back to the blood, and it works in conjunction with lymphoid organs like the spleen. And we're going to have another talk just on the lymphoid organs. The lymphatic system has three parts. It has the vessels called lymphatics. It has the lymph, which again, that's just the fluid that's left the blood, including some large proteins that's now in the interstitial fluid. And once that interstitial fluid enters back into the vessels, the lymph vessels, we call it lymph, and then lymph nodes. And the lymph nodes will clean the lymph. And so what's important about the lymphatic system is it allows us to be able to kind of recycle that fluid that bathes our tissues, take that fluid, have its own return system, and then while that fluid's being returned to our circulatory system, it's being cleaned by those lymph organs. So the lymph system is really tied hand in hand not only with the cardiovascular system, but also with the immune system, because your immune system is going to be working to clean that lymph. So the lymphatic vessels, these are the green things, and you'll notice they're going to run very similarly to where the arteries and veins run. And again, they're going to return that leaked plasma and some large plasma proteins back to the blood. It's one way, so whereas the arteries and veins make kind of a continuous loop with the heart, lymphatics are not a continuous loop. It's a one-way system. So the lymph always flows toward the heart. So you're going to have, here's the terminal end here, and here's a terminal end here. It's always going to go back toward the heart. And the way it gets to the heart is these lymphatic vessels coalesce to form what are called large ducts, and I'm going to talk about that in just a second. And those ducts will empty into the venous return near the vena cava, and I'll give you some more specifics on that in a minute. These lymph vessels, they include the lymph capillaries, the collecting vessels, and the lymphatic trunks and ducts. I said trunks and ducts. Try to say it at the same time. So the lymphatic capillaries, these are going to be similar to blood capillaries. They're going to be in association with your blood capillaries, but they're different in that they're very permeable. Okay, so they're kind of like the capillaries, but they're really, really permeable. And the reason they're so permeable is they have these endothelial cells that overlap, making these little mini valves. Do you see this little space here? It's like a little valve. The endothelial cells can kind of flap open and allow large things to enter into the lymphatic vessels, including lymph and plasma proteins. But because they're so permeable and those flaps can allow such large particles in, you can take up proteins, cell debris, pathogens, and even cancer cells. And so this is one way that pathogens can travel throughout our entire body, is once they get into the lymphatics, then if you go back to that picture, so here's my little person, okay, I know I can draw great. As those lymphatics drain back to the vena cava, once anything that's in the lymph goes into the vena cava, that goes directly to the heart. Well, we know what happens when things go to the heart. Eventually it's going to wind up in the aorta, which means it can go all the way out through the body, okay? And so that's important if someone has cancer, so say they have maybe breast cancer, and so you've heard them several times say, well, we checked the lymph nodes were clean, or we found cancer in the lymph nodes. If cancer is in the lymph nodes, that means it can spread. Once it's out into the lymphatics, now it's in the lymph nodes, it can easily get to those lymphatics drainage points, go straight into the heart, and then right out the aorta and all throughout the body. So it's real important when people have cancer to check those lymph nodes and see how far it has spread. You don't have any lymphatic capillaries in your bones or teeth or bone marrow or your central nervous system. Okay? And so these lymphatic vessels are going to kind of come together and form what are called lymphatic ducts. And there's two large lymphatic ducts. There's one on the right side, which is going to drain the upper right arm and the right side of the head and thorax. And the thoracic, which is going to basically drain everything else. And we don't call it left because it drains more than just the left side. I'll show you a picture in just a second. So you can't call it the right and the left. It's the right lymphatic duct and the thoracic duct. And each of these empties into their own port, which is where the internal jugulars and subclavian veins come together. So if you may not have worked on your blood vessel labs yet, but there are arteries that take blood to the head called the carotids. Well, blood comes back down the jugulars, and blood goes out to your arms through the it goes out, it goes through your axillary, brachial, and out to your arms. It comes back, and it's going to join those jugulars at something called the subclavian. And so again, you may not have quite gotten to your blood vessel labs yet. If you have, then this makes sense. If not, it'll make a little more sense when you do your blood vessel labs. But where these are kind of coming together, these two veins are coming together, here's where those thoracic ducts empty in their lymph into the blood circulation. Well, the subclavians, these are going to then kind of come together to form the vena cava. And if you remember, the vena cava goes straight into the heart. Okay, so those of you who've started learning about your blood vessels and how blood's flowing through the vessels, that might make a little more sense. For some of you, you may not have watched those videos quite yet. So this is what this looks like. This has got two colors. There's green and red. So the right lymphatic duct drains everything on the right side, right arm, right side of the upper abdomen, right chest, right head. The red is everything else. Okay, so that's the thoracic duct, which is why you can't call it the left side, because it drains the right leg. Okay, and so again, this is one-way valves or one-way vessels. So the lymph's going to collect from both legs. It's going to travel through this thing called the cisternae here, travel up the thoracic duct, and then empty into a port right there, right into the blood supply. On the right side, it's going to travel here and through the chest, and it's going to empty in on that side. Okay, so they're both going to join the venous circulation where those carotids, I'm sorry, where those jugulars and subclavian veins come together. All right, so because it's a one-way system of tubes, there's no pump. Okay, so whereas the blood had the heart pumping and pushing the blood out the arterial side, and remember how the veins, how the blood comes back to the heart, you have that venous return, which includes the muscles kind of milking the veins and kind of pushing that blood back up the venous side. You have those valves. You have the respiratory pump and the muscular pump. So if you don't remember that, go back and think about how you return venous blood to the heart. Lymphatic system works very similar. It uses those muscle pumps and that respiratory pump. So that's what's kind of pushing that lymph toward the heart. And just like veins, it's got valves that prevent backflow. And also, because it's in close contact, and you find them near the arteries, as the pulse is going through the arteries, that actually helps to move the lymphatic or lymph back to the heart. And in some of the lymphatics, there's actually some smooth muscle that will contract and help push it. So it works very much like venous return, again, there's no heart, there's no pump to push it through, so it has to kind of rely on these secondary methods of return. You have cells that are inside the lymphatics, and the main cells we're going to talk about are the lymphocytes, and they're the main, what I call the warriors of the immune system. When we cover the immune system, we'll find out more about that, but if you remember from blood cells, you had neutrophils, basophils, eosinophils, monocytes, and lymphocytes. So these lymphocytes, they're going to start out in the bone marrow, and then they differentiate into T cells and B cells, or T lymphocytes and B lymphocytes. And these are the cells that protect against antigens. So remember, from blood typing, antigens are things that we consider foreign, okay? So like bacteria, viruses, mismatched red blood cells, cancer cells, they're going to recognize things that are foreign and mark them so that we can then dispose of them. Our immune system can take care of them. So when we think about B cells and T cells, we'll talk about this a little more with the immune system. Your T cells are kind of your killer cells. They attack and destroy cells. And your B cells, they make the antibodies, okay? And antibodies can mark the antigens so that other cells can come in and phagocytize those. So again, T cells can kind of go out and are like killer cells, and B cells make antibodies. And again, we'll do more information when we talk about the immune system. There are a few other cells that are found in this, which are called lymphoid cells. You have macrophages. They're the ones that help phagocytize things. They'll actually help T cells do their job. You have what are called dendritic cells, and they can help the T cells. They capture antigens, so they capture things that are foreign and deliver them to the lymph nodes. When someone is sick, a lot of times they'll try to feel around your neck and under your arms, and they'll try to feel those lymph nodes. If they're swollen, there's a lot of lymphocytes in there, a lot of cells trying to mount an immune response. A lot of times you'll have some pain and swelling in your lymph nodes if you've got an infection. And then you also have what are called reticular cells, and they make a fiber that kind of makes the skeleton, kind of supports this whole system. So here's a macrophage here. You've got these reticular fibers that kind of form this scaffolding for the lymph nodes, some lymphocytes, and then of course just this big sinus area so that the lymph can flow through. And so as the lymph flowing through this big sinus like a sieve, the macrophages and lymphocytes can monitor and catch anything that's we consider foreign. All right. So that's going to be the end of this lecture, and then I'm going to talk to you about the different lymphoid organs in the following talk. Thank you.